What's up, guys? This is Bruno, and here you have my email. We are going to discuss today the questions 14 to 17. They are from your problem set number 4, okay? So feel free to write me to, ask whatever you want to ask or whatever. I'm here. So the first question is the following. Suppose that the graph below represents the market situation for a monopolist. So we know it's a monopolist, okay? Which area or areas represent a deadweight loss? So we need to start this to solve this question. The first thing is we have 3 curves and they don't have labels, okay? So which curve is which one? So you know that when you have this price and quantity schedule, or quantity price because X comes first, right? So quantity price schedule, you have usually an upward sloping curve that is the supply curve and a downward sloping curve that's a demand curve. Here we have 2 downward sloping curves and 1 upward sloping curve. We usually label the curves in a monopolist situation as the upward sloping curve is the marginal cost, because marginal cost is associated with the supply curve, and we have 2 downward sloping curves, the demand and the marginal revenue. I'm going to put which one is which one here. Marginal revenue. So why the marginal revenue is lower than the demand curve? I'm going to show you a numerical example for that. But the first important thing, put labels, okay? So you know which curve, which letter is representing which curve. And what's the solution for this kind of exercise? Or another name for solution, what's the equilibrium? In a monopolist exercise is marginal cost equals to marginal revenue, right? So we have the equilibrium is MC equals to MR, okay? But I have 2 numbers here, 1 and 2. First of all, we know that when you have a monopoly, we have this relationship. So the demand is higher than the marginal revenue. And when you have perfect competition, you have a situation in which the demand equals to marginal revenue. Why this happens? And why and how I know that the demand is higher than the marginal revenue? So I have a numerical example here. This is not from your book. I created this example, okay? So here we have perfect competition and monopoly, right? Two different kinds of market structures. And we have quantities going from 0 to 10 in both cases, and the price, total revenue, marginal revenue, cost, and marginal cost, okay? So what's the price for a perfect competition situation? As you know, perfect competition is a kind of structure in which the firms are what we call price takers. They get the price from the market. They cannot affect the price with the things they do, right? So that's why I have a constant price here. As you can see, all the prices are 10, okay? What's the total revenue for a market with these quantities and these prices here? So as you know, total revenue is P times Q, or price times quantity. So 0 times 10, 0. 1 times 10, 10. And you can follow this here, or you can just see the formula here. Okay, so the total revenue for the perfect competition is just to take the quantity and multiply the price. With this, we can calculate the marginal revenue. What's the marginal revenue? The marginal revenue is the increment from this guy, for example, this guy here, in comparison with this guy. So what is the variation from here to here? It's 10. What's the variation from here to here? It's also 10. And from here to here. So what's the difference between the marginal revenue? So when I say, let's get here, for example, what's the marginal revenue? This 10 here. It's the marginal revenue associated with 4 units, and the marginal revenue is 40 minus 30. These two guys here give me 10 here, right? So this is how we calculate marginal revenue. The cost, I'm going to erase this here. The cost, I just put, I create this example to have this upward sloping and increasing sloping curves. So when you have 0 here, when you produce 0, your cost is 0. When you produce 1, your cost 1. When you produce 2, your cost is 2, 3, 10 here. And you can continue this list here. So what's the marginal cost? Is the variation, for example, from here to here. From 0 to 1, the marginal cost is 1. From 1 to 4, the variation is 3, right? So as you can see, when you plot this in this graph here, the graph in the left-hand side, this one here, you have a upward sloping and increasing sloping marginal cost and a constant marginal revenue. As you can see, the price here and the marginal revenue here, they are equal. The price is the demand curve in that case. You know, I'm not going to explain you mathematically why, but this is the inverse demand relationship. But what you need to know is that this price here in perfect competition is the demand curve. So as you can see, the red curve on your left hand side, the red one, is both the marginal revenue and the demand curve. If you do the same exercise here, so as you can see, we have the same quantities, we have the same cost structure, okay? So it's the same cost structure, I'm selling the same quantities. However, because I am a monopolist, if I want to increase the quantity that I'm producing from 0 to 1, for example, and my first price was 0 as before, I need to reduce the price that I'm putting on the commodity that I'm selling. So for example, if I sell 0, I can charge $10. If I sell one quantity of what I'm selling, I can charge $9. If I sell 5, I'm going to charge 5. And as you can see, we have a decreasing price here. So this is the difference between the perfect competition and the monopolist situation. In perfect competition, the price are given. As you can see, the firm cannot affect with the quantities that they are choosing, they cannot affect the price. But the monopolist is what we call a price maker. He is affecting the price because he's choosing to produce more units. And when you have this price structure here, you can calculate the total revenue as before, P times Q. So you have this total revenue here, and here's the marginal revenue as before. So for example, why we have 3 here. So 3 is associated with 4 units, and it's the difference between 24 and 21. This gives us 3, right? And if you do this for all the quantities, you have this marginal revenue curve here. So marginal revenue is here. And the cost is the same as before, so the marginal cost is the same as before, okay? So we have upward slope curve, that's the marginal cost, and 2 downward sloping curves. One of them is the demand and the other is the marginal revenue. As you can see, price is demand, as I told you. If you compare price with marginal revenue here, you can see that this column of marginal revenue is lower for each number comparing to price. For example, 9 is equal to 9, 7 is lower than 8, 5 is lower than 7, and you can check with all the numbers. And if you want to have to take a look on that in your slides, So here, as you can see, in a perfectly competitive market, here I'm reading this part here, okay, perfect competition, price taker. You can just pause the video to read if you want. And when you have the monopolist situation, where's here, price maker, okay? So price taker in your left hand side, price maker in your right hand side. And this gives us some tools. For example, if I want to express from the standpoint of the firm, okay, so number one here, this number one here match with this number one, and this number two with this guy here, okay? So so let's change here just to be consistent. So in a perfect competition situation, you know that the firm's price taker, so demand equals to marginal revenue, right? And you have an upward sloping curve, which we call marginal cost. And the equilibrium is in the point which demand equals to supply. So this is the quantity of equilibrium, Q star, and here's the price of equilibrium. That's the why I told you before that the demand curve is the price in that table I was showing in the Excel, right? The other situation is the situation in which you have upward sloping marginal cost, a downward sloping curve, and another one that's a lower curve. So this guy here is demand, marginal revenue. This part's not important for your exercise, but it's important to understand how the things work, okay? And this is the equilibrium condition. So marginal cost equals to marginal revenue. It's this point here, right? So we start from here to here. Let me put this function here so we have a straight thing here, okay? So we have, this is the condition for equilibrium, and we get this condition and we go to the demand curve and we see what's the price that they're going to charge, okay? So the equilibrium here is going to be, this is going to be P star and Q star here, okay? So this is not important for this exercise. As you can see, the question here is about deadweight loss, but now you know why from the standpoint of a firm in a perfect competition situation, you are a price taker because you take the price that's given from the market, and why you are a price maker in a monopoly situation because you can affect price with your behavior, okay? So now, to have the deadweight loss discussion, let's just go back to this graph here, and let's say that this is a graph in which you have both perfect competition and monopoly in the same graph. How? So the first one is, I'm going to use blue for perfect competition. So let's put here in blue, and red for monopoly, okay? So in perfect competition, what's the equilibrium? Supply equals to demand. So demand is here and supply is here. They are matching here, right? So the quantities and the prices in equilibrium are Q0, Q0, and P1, right? This is for perfect competition. And for the monopolist situation, you get the marginal revenue equals to marginal cost, and this is the point in which both curves are intersecting. So the quantity is this guy here, and the price, is this guy here. You get here, you match here, and you go to the price, okay? So P0, Q1. This is the two pair of points in which you have perfect competition and monopoly, right? So let's put here in this table that I have here, I have PSCSSW. It's producer surplus, consumer surplus, and social welfare. PC, perfect competition, monopoly is monopoly, and variation I'm going to explain after we put the values here. So Let's say that we're going to start with perfect competition. What's the producer surplus under perfect competition? So the producer surplus is, producer, remember, is associated with the supply curve, and supply curve here is the marginal cost. So everything that is above this curve and below the price. What's the price? Is the price for perfect competition. The price for perfect competition is the price in blue, okay? So everything that's above the red curve and below the P1. So we have D plus E plus F plus G. So this part here, right? What's the consumer surplus in the perfect competition situation? So perfect consumer surplus is everything that's below the demand curve. Demand curve's this one here, and everything that's above the price. So it's this area here, right? So when we put the labels here, it's A plus B plus C, okay? Social welfare is just the summation of both of them. So A plus B plus C plus D plus E plus F plus G, okay? Now let's go to the monopoly situation. What is the producer surplus under monopoly? So it's the same thing. Producer surplus is associated with the producer, and the producer is the marginal cost. So everything that's above the marginal cost and below the price, okay? The price of equilibrium in that situation is P naught. So what is above this MC and below P? It's this part here, right? So what we have A plus B plus D plus E plus F. So A, B, D, E, and F, this part here, okay? And what is the consumer surplus in that situation? So the consumer surplus, I'm going to put this like this here, because what is the consumer surplus? Everything that's below the demand curve and above the price. It would be this area here, but we don't have a letter here, okay? So I'm going to let this blank, okay? So what is the monopoly social welfare? It A plus B plus D plus E plus F. So variation, what's the variation? Variation I put here, M minus PC. Monopoly minus perfect competition. So get this part here and subtract this part here. This is going to be the variation, okay? So A plus B plus D plus E plus F minus PC. What we have? A plus B minus G. And if we do this here, we have minus A minus B minus C. And the summation of these guys is minus C minus G. So what is this guy here? Minus C minus G. This is what we call the deadweight loss. Oh, that's bad. Okay, deadweight loss. So the answer here is C plus G. Okay, and this is this area here. Let's put in green. So this area here. Why this is this the area? Because we are in the monopoly situation, the red one, we are working under this quantity, and under the perfect competition situation, we would operate under this Q naught. So we are losing this quantity, and this is the variation of prices that we are charging. So this gives this area here. Okay, let me erase all of this. Okay, so this is the answer for this one. And with this, I just have this table here that I did before. On the question 15, suppose that the graph below represents a market situation for a monopolist, as we know. Which area or areas represent the amount of producer surplus that would have been consumer surplus in a perfectly competitive market? It's a weird question, but what they are asking is the following. What is here? So let's put the same color here. What area or areas represent the amount of producer surplus that would have been consumer surplus in a perfectly competitive situation? So what is here that was here? This is the question. So what do you have here that it was here? It's A plus B. Okay? And this is the answer. So what we are saying is that when you have perfect competition, the consumer surplus is A plus B plus C. It's this guy here. Okay, I'm going to erase this. Okay, it's this guy here. Let's erase this as well. So when you have perfect competition, the consumer surplus is A plus B plus C. When you have the monopoly situation, you transfer A and B. These two guys go here and here. And C is loss, as you can see here, is the deadweight loss. Okay, so this is the question here. Which amount represent the producer surplus that would have been consumer surplus in a perfectly competitive market? Or it's this area here, A plus B. It's this here. Okay? So just compare two situations and what was in one situation that would be in the what is in one situation that would be part of the other one. This number 16 is the following. Suppose that the graph below represents a market situation for a firm under monopolist competition. What would be what would each curve represent? There's no problem. We have MCD and MR here, and we need this. So we know that this is the graph. Let me get here. This is the graph for monopoly right here. Okay, so you have this in the monopoly. So the upward sloping curve, marginal cost, downward sloping curves, D and MR. With this, you can answer this question. If you just want to answer this question, A is MC, so you can delete this one, and this one. Those guys are not MC. And letter C, you know that's the demand. So C is demand, correct here. C is marginal revenue, so you know this is going to be the answer. Just double check. D is MR. D is MR. It's okay. Okay. So this is the answer, but why this is the answer? So remember the following. The total cost for a firm equals to the fixed cost plus the variable cost, right? Or TC equals to FC plus VC. VC, not E. So if you get this here and divide both sides by Q, by the quantity, you have, TC over Q equals to FC over Q plus VC over Q. I just divide both sides by Q. The total cost divided by the quantity is what we call average total cost. The fixed cost divided by quantity is the average fixed cost, and you probably can anticipate that this is going to be average variable cost. And I can anticipate to you that's going to be the cost here. I'm going to explain why. So let's get just the fixed cost. Okay, The fixed has this name because it's fixed. That is, let's say, the fixed cost, you have to pay the rent of $100. You have to produce something, then you need to rent a space, and you have to pay $100, regardless the quantity that you are producing. So let's say that your quantity equals to 1, so you're producing 1 unit, quantity equals to 5, or equals to 10. These are 3 different situations. What is the average fixed cost in each of them? It's the following: 100 by 1, so it's fixed cost divided by Q, 100 by 5, and 100 by 10. This is going to give, in each case, 1, 20, 10. So as you can see, the quantity is increasing and the average fixed cost is decreasing, right? What happens with the variable cost? Variable cost is basically the cost for producing each unit times the quantity that you are producing. Let's say, for example, you have $5 per unit, okay? So if you want to produce the same numbers, Q equals to 1, equals to 5, equals to 10. Then the average variable cost, it's going to be the following. It's going to be 5. It's cost times quantity. 5 times 1 equals to 5. Here's 5 times 5, 25. And 5 times 10, 50. So as you can see, the average variable cost is increasing. So when the quantity here goes up from 1 to 10, for example, 1 to 10, 1 to 10, the average fixed cost here is decreasing, and the average variable cost is increasing. So that's why we have this curve here that starts with one behavior. Let's put another color. Starts with one behavior and express another behavior. So it decreases and then starts to increase. That's why the reason for this kind of shape for this curve is that, for example, let's say from here to here it's decreasing, and from here to here is increasing. So here the fixed cost dominates, and here the variable cost dominates. As you know, the fixed cost goes down, the variable cost goes up. And you can see that, for example, let's say that you are producing 100. So what is the fixed cost to produce 100 units? It's just 1. What's the variable cost, though, or the average variable cost to produce 100 units? 5 times 100, 500. So in small quantities, this guy dominates. In high quantities, this guy dominates. That's why this curve here, let me just erase all of this. This guy here, as you can see here, is the average total cost. And the explanation is in this slide here, in this page here. And the last one, we have the same graph, and the question is the following: is the monopolistically competitive firm in the graph below operating at the long run equilibrium? So is this the long run? So let's put here marginal cost. We know that's average total cost, demand, marginal revenue. Okay, these are the labels. You need to remember two conditions. One, equilibrium, marginal cost equals to marginal revenue. Okay. So here, marginal cost equals to marginal revenue. It's this part here. Okay. So as you can see, marginal cost equals to marginal revenue in this point, and we go to the demand curve. Okay. You know how to do this. The second thing we need to remember was the definition of profits. profits is the same as the revenue minus cost, or pi for profits equals to, let's put total revenue minus total cost. I'm just putting total, but it's not necessary. Revenue minus cost is the same. And what's the situation in which you have when you have pi higher than 0? That is, when you have positive profits. If total revenue minus total cost it's higher than 0, it's the same to say that total revenue is higher than total cost. But this is not so helpful in this exercise, so we need to express this in another format. It's the same thing, but just a different angle to the same thing. So pi profit equals to, what's total revenue? P times Q, price times quantity, minus C of Q. This notation here is just to say that it's, for example, when you have y equals to f of x. So the variable y is a function of x. If you plug x here, you have 1y. Here we are saying that cost is a function of quantity. Okay? Just that. And I'm not saying that's a straight line or a parabola or whatever. I'm just saying it's a function. Okay? So let's get this and divide both sides by q. So pi over q equals to p times q over q minus c of q over q. This is the same as pi over q equals to p minus c over q is the quantity divided, is the cost divided by the quantity. Here, total cost divided by quantity, we call average total cost, remember? So here, average total cost. If you multiply both sides by q, or if you isolate pi, you have this pi equals to q multiplied by p minus average total cost. So if you want to have pi higher than 0, you need to have q higher than 0 or p minus atc higher than 0, right? We could have, for example, two negative numbers multiplied, they give you a positive number, but you cannot have a negative quantity. You cannot buy minus 5 shirts, you know? So we need q higher than 0 or p minus atc higher than 0. And this guy here is going to give us p higher than atc equals higher than atc. This implies pi is positive. So in this situation here, what do we have? We have the price is here, right? Because this is the point they are operating. And when you get this price and you go to the average total cost, you are in the same part here. You are in the same level. So here in this exercise, we have price equals to average total cost. And if you plug this here, you have pi equals to q p minus p, for example, or 0. Okay, so the answer for this exercise is the following. Yes, we are operating in the long run equilibrium. Why? Because the firm has zero economic profit. Zero economic profit is the idea that if you have, for example, you are working in a firm and that firm or that sector of that firm has a positive profit. This is going to make the other firms want to go to your sector. Okay, so when you have positive profits, you have an incentive to other firms to enter in your market, and they are going to enter in your market or in your sector or whatever, and this is going to bring the price down. And if you have the opposite, is going to have, if you have negative profits in your firm, in your market, you're going to say, okay, I'm doing I'm having a loss here, so I'm going to move my capital to another market to try to make some profit. So you're going to reduce the entry of firms, or you're going to decrease the number of the firms, and this is going to bring the price up. So I think with this we are done here. If you have any questions, just email me, or you know how to find me. I hope you guys are safe, and any questions that you have, I'm here to help you guys. Okay, see you.